The issue is that we have 3 different anti-PD-L1 antibodies in the market now, and we have, or at least in clinical trials, and we have 2 PD-1 antibodies that have been approved in various places. And the question is, are there real differences between these antibodies? How do you choose which one is better than the other, if there is such data, and what do you do to sort of try to differentiate these antibodies from each other? So the basis of my talk was that one of the antibodies under the category of PD-L1 inhibitors called Avelumab has an additional property called ADCC, which stands for antibody-dependent cellular cytotoxicity. It is a property that, from a clinical standpoint, has been difficult to prove that it actually happens, but in a laboratory setting and experimentally, you can show that it is an important component of some of the antibodies that we use. So the gist of my talk was that perhaps by coming up with strategies to magnify the ADCC component of this particular anti-PD-L1 antibody, we can differentiate it from the other ones, perhaps in the setting of using it for patients who don't have very robust responses to single agent anti-PD-L1s, or coming up with other molecules that could modulate ADCC to make the antibody work even better. So that's what I concentrated my talk on. I think we're still in the experimental stage of it. We don't really know how to best augment ADCC. I presented some data from other labs where through some very interesting genetic manipulations and studies, they've been able to find, for instance, if you inhibit a particular pathway in conjunction with an antibody that induces ADCC, you get much more lysis of cancer cells. So it gives us clues and possible ideas about future clinical trials, but I think we need to do some more work before we head in that direction. At this point, it's sort of a theoretical, lab-based, and we have to see if it's translatable into the clinic.